We're group 5 and we're doing a semi-parametric empirical Bayes theorem, and we're focusing on the binomial case. So we're just going to work a couple of SOA problems that are relevant, and the first one that I'm going to show you is SOA problem number 62. So the problem is, an insurer writes a large book of home warranty policies. You're given a maximum of 1 claim may be filed per year. The probability of a claim varies by insured, and claims are independent between the policyholders. The probability of a claim for each insured remains constant over time. So it's semi-parametric, but it doesn't specify any distribution. But from these first 3 things, especially because we can tell there can only be a certain number of claims, and each insured has a constant probability of claims. So we know that this is binomial. And if we want to, we'll just call the random variable for the expected number of claims, or the number of claims random variable x. So x is binomial with parameters n and q. And from up here, since a max of 1 claim may be filed per year, we know that this n is equal to 1. Now, the overall probability of a claim being filed by a randomly selected insured in a year is 0.1. So that is the overall Q that we're looking for, and that would be the expected value of Q is 0.1. But in this case, we know that n is 1 also, so this would be equal to the expected value of n times Q, which would be mu, because that is the expected value of a binomial distribution. Now, this one right here, the variance of the individual insured claim probabilities is 0.01. So for just one individual, the variance of their Q is 0.01. Now, an insured selected at random had 0 claims over the last 10 years. And since we're calling X our claims random variable, 0 divided by 10 is 0, so that means our X bar is 0 also. Now we want to find the Bullman credibility estimate of the expected number of claims that this selected insured will file over the next 5 years. Yeah. Okay, so in order to find the Bullman credibility estimate for the expected number of claims for the next 5 years, we need to find the credibility factor. So these were the things we concluded from the given things in the problem. And we know that the credibility factor is this equation, this z, where n is the number of years for data which we have, and EPV is the expected value of the process variance, and VHM is the variance of the hypothetical means. So for a binomial distribution, which we are calling x, we know the expected value of x equals nq, and the variance is nq times 1 minus q. And since n is 1 in this case, this is equal to q, and this is equal to q times 1 minus q. Now we can think of this as our hypothetical mean, and we can think of this as our process variance. So we want to take the expected values of the hypothetical mean and the variance of this, the variance of the hypothetical mean and the expected value of the process variance. So the variance of the hypothetical mean will be the variance of Q. Now, we know that that is equal to 0.01. That was given in the problem. So for the expected value of the process variance, we need the expected value of Q times 1 minus Q right here. And we don't know this, so we go ahead and distribute the Q within the parentheses and get this. And since it's an expectation, we can actually separate these So to find the expected value of our process variance, we're going to have to find this expected value of q squared. We know that the expected value of q is 0.1 from the problem, and to find this expected value of q squared, we just go back to the definition of variance. So the variance of q is equal to 0.01, which is also the expected value of q squared minus the expected value of q quantity squared. So this is equal to, the expected value of q is 0.1, so expected value of q squared is equal to 0.01. So from that, we can conclude that the expected value of q squared, is 0.02, just by solving this equation. So the expected value of the process variance will be 0.1 minus 0.02, which is 0.08. So now we have everything we need to solve for our credibility factor. So z will be equal to n, which is 10, over 10 plus 0.08 over 0.01. This is equal to 8, so this is 10 over 18, which is 5/9. And we want to find the expected number of claims in the next 5 years. So first of all, we're going to have to find the expected number of claims for the next year. So that is just the same formula as the credibility premium, which is z times x bar plus 1 minus z times mu. And x bar is 0, as we had in the problem, and mu is 0.1. So this becomes 5/9 times 0 plus 1 minus 5/9 times 0.1. So that's 4/9 times 1/10 equals 4/90. And it's actually pretty simple to, I guess, extrapolate this to the next 5 years. All you do is take the estimate for the next year and multiply it by 5. So we have 4/90, apologize for my handwriting, times 5 equals 20/90, which is about 0.22, which is Andrew choice D.
Hi, I'm Tiffany. I'm gonna do SOA problem number 133. The problem gives us the annual number of claims for an insured has a probability function, which we can tell by this distribution function. It's a binomial distribution with n, little n equal to 3. And the problem also gives us a prior density of the pi equals 2q, which is the density function for q. And it says the random chosen insured has 0 claims in year 1, which means the x bar is 0 claims over year 1, which is equal to 0. And the problem asks us to estimate the number of claims in year 2. And we have this estimation function is if you want to estimate, we have a formula for it, which is so we have to find mu first, and we have the distribution function with the binomial distribution. Expect the value of x given q is nq, which is 3q, because n equals to 3. And then we need to find the variance of the given insured. nq times 1 minus q, which is 3q times 1 minus q. So mu equals to the expected value of 3q, which is we take the integral from 0 to 1, 3q of the binomial distribution times the density function of q dq. And if you do the integration, you'll get 2 for mu. And moving on, we have to find z, which is our probability factor. And z equals to n over n plus EPB, our expected process variance, over VHM, the variance of our hypothetical mean. To find EPB, which is, you'll take the expected value of our process variance, which is 3q times 1 minus q. And take the integral from 0 to 1, 3q, 1 minus q, times the density function, 2q, dq. And by doing that, you will have 0.5. Then we have to find VHM, which is the variance of our hypothetical mean, which is 3q. And you have to take the integral for 3q times the density function. Oops. Scratch that. It's actually expected value of, if you spread this out, it'll be 9q squared minus mu squared. And we know mu, so we just have to find the expected value of 9q squared, which is integral of 0 to 1, 9q squared times the density function dq, and minus mu squared. And you will get 0.52. So plugging back to the equation we have right here, it'll be, oh wait, you have to plug it back to z first. So z is n, n is equal to 1, because we have information over 1 here. So it's 1 over 1 plus EPB over VHM, which is 1 plus 1, 1 over 1 plus 1, which is 1/2. Then plugging back to the final equation, which is 0.5 times x bar we got, which is 0, plus 1 minus z times mu, and you'll get 1, which is our final answer.